Hi everyone, my name is Bryant son. I'm a consultant at Red Hat, which is an IT company doing open source software, but also mostly well known for Red Hat Enterprise Linux Server, RHEL, which is used by so many corporations nowadays. But today, I'm here as a opensource.com correspondent, which is basically a role I'm writing something for opensource.com and also moderator. Opensource.com is the Red Hat sponsored blog contributing to talking about open source tools and practice and many interesting topics. And you can get involved as well. So I wrote a number of different articles at opensource.com already, covering CI/CD, continuous integration, continuous deployment, and then DevOps, BI improve, and many different topics. But today I'm going to talk about what makes this website secure and how can also secure your website using open source tools. So there are different open source tools out there that can help you with the process of making the website secure using that something called certificate. But before talking about and explaining about how can you secure a website and generate a certificate using self-signed certificate, I want to give like a little introduction to what makes a website secure using HTTPS. And I want to then cover give a little introduction to Internet Protocol using TLS and SSL, which is one of the two protocols. And then I want to then explain, I'm going to move on to talking about certificate authority, known as CA, and self-signed certificate. Lastly, I want to give like a little introduction to open source tools to generate a certificate and give like a list of them. And lastly, I want to kind of go through that how you can create a self-signed certificate by yourself, which is by using one of the most famous tool for that is called OpenSSL. So that's going to be the topic today. And without further ado, let's get started. So most websites today, especially publicly facing website, is you can think them as already secure. If it's not, well, that's going to be kind of a problem, right? So like if you go to be a bank website or any other like Facebook or social network, anything that requires login or some kind of secure transaction, you can kind of expect the website to be secure already. Otherwise, oops, that's going to be a problem. Since we are at opensource.com, let's visit opensource.com and then check out the certificate. So most of the time is when depending on the browser, it might look a little different. So, but otherwise it's still similar. So I'm here at opensource.com. Most of the times when you look at the browser at address bar like this at the top, you will see like logs icon like this. So you can click this icon and verify that connection is secure and it has cookies information, but where we wanted to say that we want to kind of see the connection is secure, which means it has certificate. You can most of the times in most browser, you can even click certificate and so to the detail to see that what is this certificate about. So you can kind of verify that this information, and you can also see the certificate authority, which is in this case is DigiCert, and then like where it's based at and etc. So you can kind of see that if I get information about this is website secure, and what makes the website secure is that the number of different things is that it needs to have a valid certificate. So that's kind of how you can verify the website secure. Now, since we talk about what makes a website, how to check the website to be secure, I kind of want to give a little introduction to something called Internet Protocol. So back when the internet was defined in sometime in the 1960s, although the actual website what we see as World Wide Web today didn't came until 1990. This was defined about how to define a network itself. So there is something called internet protocol or layers, and protocol is a layer, and normally it breaks down into about 6 different layers, so to say. So the most basic fundamental one that actually govern is something called physical layer, which is you're talking about something called the hardware itself. So when you talk about the router and the Wi-Fi and all those things kind of goes underneath here. Then we have a data layer, which is Ethernet and token link. It can be Wi-Fi, whatever it is. But this is basically the data transaction layer. Then we have a network layer. You probably heard of something called IP or Internet Protocol, so which is a required defined address of the website. So when you visit www.opensource.com, it has certain IP attached with that. So this is kind of like a way it's identified and subnet and break down all those different underneath. Then we have a transport layer. You can think it as website when it's when you visit opensource.com, for example, it has to hit and send a message, right? So this is what we call as TCP UDP, which is kind of out of scope for this blog or article, but you can read more in detail. But basically, this is a message transaction that just contains the data. Lastly, we have an application layer, and you've heard about HTTP website, HTTPS website, SMTP for email, FTP for file transfer protocol. But under the application layer, some people say that it's actually quite a separate layer, middle layer between application layer and transport layer. But we have what we call a security layer, and this is where the TLS and SSL comes in. Previously, we have a SSL or a security socket layer, and then TLS came in, which replaced SSL, transport layer security. So it's kind of hard to explain without going through all the different explanation about like a network. What make a network as network? But you can, at the moment, you can kind of think them as a layer or protocol that makes to encrypt the website and also basically encrypt the website so the message and all those things transaction can be hidden and encrypted. So there's way to think about SSL and TLS, and this is where the certificate comes into play to make the website secure. So when you work on a website, you are trying to go to production. So when the website goes to production, which is publicly facing, you need to have a website secure using certificate, which is TLS or SSL certificate. Most of the times, there are trusted certificate authority, CA, that is actually required to sign the certificate itself. So people can say that, hey, this is actual website secured by trusted vendor, CA. So you previously saw that opensource.com was using DigiCert CA, but there are also other vendors out there. You can Google certificate authority providers that comes with DigiCert, GoDaddy, VeriSign, and many other certificate authority providers. The problem is that whenever it goes to production, whenever your website has to be in the public, yeah, you need a certificate authority for sure. But when you start working on the website first time and try to host it and test it out, that a certificate authority signed certificate might be too much work and require too much money, like $1,000 or more. So this is where self-signed certificate comes into play. So self-signed certificate is basically a way for user to generate certificate for free. But again, it is not a replacement for certificate authority because you still need it whenever it goes to the production. But regardless, there are many open source tools out there to help you to generate self-signed certificate and also manage the actual CA signed certificate. And probably the most famous open source tool to accomplish that is OpenSSL, most well known one out there. So I'm going to give a little demo later to how can generate self-signed certificate using OpenSSL. But basically OpenSSL is that one of the open source tool that help to generate and maintain certificate, and also is based on the Apache license version 2. So it's the open source. So let's talk about EGRSA, which is another tool, open source tool that helps to generate certificate and manage certificate. It's by from the OpenVPN, but it's based on the GPL version 2 license. So there's a GitHub page you can follow, and then you can read about it. So basically, that is actually another tool that can help to generate open signed certificate, but also manage the other certificate authority generate certificate. So just busy website out there, you can play with it, and so there's another great tool out there to help to generate certificate. Another tool that is also help to generate certificate and manage it is SSL. This is a tool by a Cloudflare, which is content delivery network or the company. So the old Cloudflare decided to create a PKI TLS based toolkit, command line interface, and again this is also open source tool, but the license is a little bit different. You can read it from the GitHub website. It's BSD 2 class simplified license, but it's open source regardless. You can read the term and condition here. So every tool has some difference between pros and cons, but it's actually very useful tool. So far we covered OpenSSL and EGRSA and then CFSSL, but there are a number of other certificate authority generating tools for free open source out there. But one thing I want to cover is a Lemur by Netflix. So it's kind of interesting because Netflix quite did some analysis on different certificate authority generating tools, and there's a blog article that covers that, so you want to read about it if you are interested. But there are plenty of documentation, and also is based on Apache license version 2, so it's open source tool. So be sure to check out if you're interested in what Netflix did, and it's also open source, so it's free to use it. So I'm going to show how you can generate a certificate using the tools that helps to do this. And then I'm going to use OpenSSL, which is one of the open source tools, but you can basically use the similar process for other open source tools to generate the certificate. It's really the 3-step process. First step is you need to create a private key using the command. And second step is you need to generate something called certificate signing request. This is basically you're acting as own certificate authority, and you need to use a private key created from step 1. Lastly, you're going to generate a certificate using both key and also SSL. So first step is you need to create a private key. But before that, most of the times, I'm using Mac right now, but also tested this using the Linux distro. Most of them already installed with that. You can enter interactive mode by going to OpenSSL. So you can generate type of command this way. But I'm going to use something called inline command, which is just I'm going to type with inline. So whenever you are stuck with the help, just do OpenSSL -help and you give it this command. So this is how you can get a help immediately. So first step again is I'm going to create a private key using OpenSSL. I'm going to use standard 2048B load modulus. So in-depth discussion what this one is kind of out of scope. You can read more detail about it. But so first command is I'm going to generate the private key, OpenSSL, and gen RSA, and I'll define the name of the the key or the how output name the key. I'm going to say example.key, and 2048 with prolonged address. So the key is going to be encrypted, as you can see. And second step is using the key. I'm going to create a certificate signed request. Again, you can think this as certificate authority by you're creating a certificate authority for yourself. So the command is open SSL request new the type and key, which is to use a key created in step 1, and hyphen out define the name of the CSR, output, and subject. This is an important part, but there's a format, and please search for the certificate authority format. I'm going to say Red Hat, and you can also space between. OU is organization unit. I'm going to say IT. Again, this can be anything, but you need to have this starting format. CN is the name of the website or whatever. Say source.com. So CSR generated, and as you can see, last step is using the key from step 1 and CSR from step 2. I'm going to change the certificate. I'm going to use something called 509. Read about it if you're interested in more details. This certificate will expire in about 1 year later, so you can define how long or when does this certificate expire. It will take CSR, sign key will be key, and out will be CIT. So this certificate are created. And you can do certificates too for your self-cited certificate. This can be Kubernetes or anything like that, or any hosted platform out there. Based on what it is, instruction might be different, but you have all the information, all the content required to import self-cited certificate. So again, if you have a self-signed certificate or certificate authority signed certificate, how you want to import and use a certificate, manage a certificate on the website is very different from what we use. Kubernetes, for example, have own ways to define and manage certificate and secure the website. So this example make sure that you follow that. And some of the things what we cover is also defined here. But so depending on what your hosted platform is, the instruction is totally going to be different, but ideally will be the same. So make sure to read the correct documentation for your own purpose, and then go with that. Yeah, that's it for this. So yes, so that's it. And I have also have other articles through opensource.com. So if you don't follow, there's opensource.com/users and BRSON, and you can find other articles regarding DevOps and something about machine learnings and etc. So if you're interested in it, please check out.